friends, welcome to John Newton online class. In this video, we want to study physics. I wanted to discuss this particular topic, that is electric field 1. Then there are some certain concepts I want us to look into, which include electric current, then electric circuit, then potential difference, EMF of a cell, terminal PD, Ohm's law, and electrical work and power or energy. So first of all, without wasting time, when we talk about electric field, of course, field in general here, by this context, we mean any region or space within which the influence of any of the physical agents can be felt, like the magnetism, like the electricity, like a gravitational field. Now, in electric field here, when we talk about electric field, we mean the region within which the charged body can be experienced by the effect of a charged body or forced by a charged body can be experienced. Yes. So in this case now, we are focusing our attention on electric current and the other allied concepts or terms. Without wasting time, what do you mean by electric current? An electric current simply means the rate of flow of electrons along a conductor. The rate of flow of electrons or rate of flow of what? Charges along a conductor. That is electric current. Then, how do we calculate electric current? What's the formula for electric current? The formula for electric current is given by I equals to Q over T. That is the formula for electric current. Because current is the time rate of flow of charge. This Q stands for what? Charge in coulombs. T is what? Time in seconds. Okay. Then, the other thing we should look into is now, what is the instrument used for measuring electric current in a circuit? The instrument is known as ammeter. You can see it here. The ammeter is used for measuring electric current. Good. And the unit of current is what? Ampere. The unit of current is ampere. Good. Now, then we have types of current. We have AC and DC. That is alternating current and direct current. By alternating current, we mean that current that's a varying current. Alternating means varying or changing current. A varying current which changes its direction periodically along the circuit. That is a varying current that reverses or changes its direction periodically along the circuit. That is what? An alternating current. That is AC. Then we can get AC like in our nation here. The power supply we get from the Kenji Dam, from down, the hydropower supply we transmit is AC. Why do we use that? So that it can be transformed by the transformer. That can be stepped up or stepped down by transformer. Then DC, direct current. What do you mean by direct current? The direct current is that steady current that flows in one direction. Although its value can vary along the circuit, but it flows along one direction in the circuit. That's direct current, as the name implies. Then, what are the ways through which we can generate electricity? Ways of generating electric current. We have simple ways of getting electricity. We can get electricity from chemical cells that are using battery. It can be dry cell, it can be lead acid accumulator. We can get electricity from chemical cells. We can also generate electric current or electricity using mechanical energy. That is, for example, using our generator or dynamo. We can get electricity using our generator, like the common generator we use in our homes and offices. That is, we can generate electricity using generator. We can also generate current electricity using solar system. From solar energy, we can generate electricity. That is photoelectric effect using solar energy. So we can also generate electricity using thermocouple. Yes, and also from hydropower source. Like here in Nigeria, we have the Kenji Dam. Yes, these are some of the ways we can generate electricity. Then, that one done. Now, let us look at circuit. Some people confuse these two terms. They misunderstand these two terms, electric current and electric circuit. When we talk about electric circuit, we mean the complete pathway provided for the flow of current or for the passage of electric current. The electric circuit is the complete pathway provided for the flow or for the passage of what? Electric current. That is an electric what? Circuit. Then, when AC current flows through that, the pathway for AC current is AC circuit. The pathway for DC is DC circuit. Then, now let's look at types of what? Circuit. Then we have types of circuit. The types of circuit, we have what they call the closed circuits. We have the closed circuit. We have the closed circuit. A closed circuit is a circuit in which there is no gap along the conducting part of the circuit. That's the closed circuit. And in such a circuit, current is delivered or current flows to the external resistor. By resistor, I mean the loads. In the common appliances, you have the loads like the lamp or bulb, even your electric fan, all those appliances are the loads. So in a closed circuit, current flows to the external what? Resistor. There is no gap in the conducting part. For instance, when you turn on the switch of your electric bulb or lamp, the switch of your electric fan, when you turn on the switch, then you say that you have completed the circuit with a closed circuit. Then, another one, we also have what we call an open circuit. An open circuit. What do you mean by an open circuit? As the name implies, an open circuit is the circuit in which there is a gap in the conducting part of the circuit. In such a circuit, current is not delivered to the external what? Resistor. In an open circuit, there is a gap, a bridge along the conducting part of the circuit. And in such case, current is not delivered to the external what? Load or resistor. Now, you can create an open circuit when you turn off the switch of your what? Electric circuit. When you turn off the switch of your electric bulb or lamp, you turn off the switch of your electric fan and the other appliances, then you see that there will be bridging of current. Then it is now an open circuit. Good. We still have another third one, which is short circuit. We have short circuit. We have short circuit. What do you mean by a short circuit? A short circuit is a complete circuit, that is a closed circuit without load. When a circuit is closed without external load, it is called a short circuit. And it is not good. It is not advisable because it drains the what? The source of power supply. But because what makes up a complete circuit? You should remember that a complete circuit is made up of simply there must be a conducting part, that is the wire. Then there must be source of power supply. It can be your battery, it can be generator, that must be source of power supply. Then there must be load or lamp, and there must be a switch for circuit breaking or completing, for opening and closing the circuit. There must be a key or switch along that. That is what give you a simple complete circuit. Okay, then there must be what? Load like the lamp or bulb. That is simple complete circuit. Okay, then we talk about another term here. We have potential difference. What do you mean by potential difference? By potential difference, we mean the work done in an electric field in taking a unit positive charge from one point to another point in an electric field. That is potential difference. The work done in taking a unit positive charge from one point to another point in an electric field. That is what? Potential difference, known as PD. And it is measured in volts. The unit of potential difference is what? Volt. That is voltage. Measured in volts. Okay. You can also refer to potential difference as the voltage in that circuit. Then we have what we call EMF of a cell and terminal PD. Of course, when you want to measure all these things, potential difference, EMF of a cell, terminal PD, the instrument, the electric circuit component or device for measuring them is the what? The voltmeter. Remember, the current is measured with what? Ammeter. Though we can detect very small amount of current with what? Galvanometer. Okay, now, by EMF of a cell, we mean the potential difference between the terminals of the cell when the cell is not supplying current or delivering current to any external load or external resistor. So the complete voltage of a cell when it is not delivering current or supplying any current to external load or external resistor is known as the EMF of a cell. For example, if you buy your dry cell battery like Tiger battery, you have the complete charge like about 1.5 volts and so on. Then the terminal PD. Then the terminal PD is simple. It is the potential difference between the terminals, the ends of the cell, When the cell is now doing work, that is when the cell is supplying current to external load or external resistor. That is the terminal PD. And it's also having a voltage drop, because when the cell is delivering current to external load, then it is expressing voltage drop. And that voltage drop is known as what? The loss voltage. So, which means that the EMF of a cell is always greater in value than the terminal PD of a cell. Because during terminal PD, there's voltage drop, known as the loss voltage. Okay, now another thing we have on the board here is Ohm's law. Ohm's law. It is very important we study this law, because in our subsequent class, we are going to delve into calculations involving some of these things we are discussing. Ohm's law simply states that the current flowing through a metallic conductor or wire is directly proportional to the applied voltage, to the voltage applied across its terminals, provided that temperature and other physical conditions are kept constant. That is Ohm's law. That the current flowing through a metallic conductor is directly proportional to the applied voltage, provided that the temperature and other physical conditions are kept constant. By expression, the Ohm's law says that V is proportional to what? I. That is Ohm's law expression, which means by equation V equals to what? IR, where R is the what? The constant known as resistance of the wire. That is it. Okay, from here we can get other similar formula. If this is the case, therefore, we can now say that I is equals to V over R as well, and the R here is equals to V over what? I. That is it. Where V is the voltage, that the potential difference applied, I is the current, then R is the resistance. Voltage in volts, current in ampere, resistance in ohms. Okay, now, having said that, let's look at what do you mean by resistance? Resistance simply means the opposition to the flow of current in a circuit. The opposition to the flow of current in a circuit. Then that device that offers that opposition is known as a resistor. It's known as a resistor. Of course, we have our standard resistor, which values are fixed, like 2 ohm, 3 ohm, 1 ohm. Then we have our variable resistor, whose values can be altered. They are not fixed. For example, we have our common rheostat as variable resistor. Then let's look at electrical work or heat or energy and power. Electrical work or energy or power done in a what? In a circuit or in heating effect of electricity. Because electric current has heating effect, it has chemical effect, like you see in electrolysis. It also has magnetic effect, like you see in a solenoid. That is it. So now electric work, these are equations. Mathematically, we have these three concepts. Let's look at this. Electric work. So electric work done in circuit given by work equals to what? QV. Work equals to QV. Which means if I use Q, I remember that I said that I is equals to Q over what? T. From here you can see that what? You can see that Q is equals to IT. So when you substitute here, the electric work equals to what? You can see how as IV what? T. That is it. Similarly, the heating effect can also be IVT. If you use H for the heating effect, like you're using electric coil or heating coil. Now, if this is the case, from these variables here, these quantities right here, so you can also say that on H equals to I square RT, and also on H equals to V square T over what? R. These are important formula. We shall make use of them in the next class. So this is the formula when the work done by electrical system, electrical devices, or their heating effect. Then in terms of power, power is equals to energy over time. So if power is energy over time, this is electrical energy, electrical works. So therefore we have power equals IV since time will eliminate time, or power equals I square R, or power equals to V square over what? R. So take note of this formula. You can see the difference in power. You remove all the T's here, you get power. So remember the unit of power is watt, and of course unit of work or energy is what? Joule. So this is a simple circuit diagram. We have complex circuit, simple circuit diagram, where this is what? The cell, where this is the key or switch, and this is the rheostat. The rheostat, that's the variable resistor I talked about. Here is what? The resistor. Here is resistor, that's standard resistor. Then this is ammeter. This is ammeter. This is the ammeter used for measuring what? Current. Then here is the voltmeter. Here is the voltmeter for measuring the what? The potential difference or the voltage in the circuit. So at this point of discussion, I believe you have understood basic concept in electricity, electric current, the types of current, ways we can generate electricity, electric circuit, types of circuit, and the potential difference, EMF, terminal PD, the Ohm's law that led us to this equation we wrote earlier, then the electric power and heat work done in electricity, how to calculate them, the formula, the important formula, and a hint of a simple circuit. So thank you for your attention in this particular class. For more of this and also in mathematics and the solutions of problems in physics, kindly subscribe to my YouTube channel. Join me on Facebook, Instagram, and also TikTok. Then remember, in the next class, we are going to delve into calculations proper that will involve this formula and the rest of them. Thank you and God bless you. For extra classes, online classes through Zoom, Skype or Telegram, as in preparation for JAM, WAEC, GCE, NECO, and the other examination, NAPTEL, and so on. You can reach out to me for online classes through my phone number here. You can chat me on Facebook or on WhatsApp, and I hold classes for you. Thank you so much.